Hi, my name is Nick Schrock. I'm the CEO of Elementl and the company behind Dagster. And first of all, I'd love to thank the organizers of this conference for inviting us and including us. It's really an honor to be here with all these other talented technologists and teams. Just a little housekeeping. There's a QR code on screen. You can use that to go into a Discord where there'll be discussion about this talk and generally about the conference. So this conference has been a series of talks where we're going through the data stack journey of a particular company that we've made up called Yukon, going through every single stage of the modern data stack with a focus on open source. And if you've been watching these in order, which I'd be impressed with, you've seen Snowplow and Meltano, an open source ingestion tool, and now you're hearing from Dagster. And you will be hearing from DBT, Superset, and Grouperoo about other phases of the data stack. What's interesting is that orchestration really could have gone anywhere. It actually might have been more appropriate at the end because we are the one that orchestrates all the different technologies that we're talking about here. So how do we view Orchestrator and its relationship to the other technologies? Very narrowly defined, we believe the purpose of the orchestrator is to manage the interoperability of all the different technologies that you see in a modern data stack or platform, as you can see in this slide. These technologies depend on each other in a variety of ways. For example, you can't run DBT until data has made its way into Snowflake or another data warehouse. And your reverse ETLs, such as Grouperoo, won't have new information to load until DBT has updated its model. The orchestrator is the centralized place where you can define the dependencies between these different technologies. Therefore, it's a centralized place to learn how data flows from one point to another, and the centralized place to see operational information such as failures, logs, and history for any workflow that you're running. If someone were to ask, where do I go to look at my data stack? We believe that the orchestrator should serve as a single pane of glass to turn to, because it is the tool that invokes all the other tools. It is a natural point of centralization for operational concerns. In essence, the orchestrator is in charge of ordering and executing the arrows in this image. With the modern data stack, you can end up using a fairly small number of distinct technologies to spin up a productive analytics platform. It can be tempting to look at the slimmed down set of technologies that the modern data stack enables and envision a set of operational dependencies that just look something like this. However, even if you're using a single tool to handle a bunch of different jobs, for example, to choose an example out of nowhere, imagine you use Meltano for all your ingest, the underlying complexity of the data dependencies still remains the same. You still have to ingest from the same number of distinct sources, which might each have their own schedules and downstream dependencies. For most users, even those using just a handful of technologies, this is not a realistic picture, and it greatly oversimplifies their reality. In some ways, the modern data stack as it's used has been a step backwards for some people. Just as a brief history of how workflow engines came to be, in the beginning, there were overlapping crons, where you would set a cron job to run, say, at midnight every night. And then if you had a job that depended on that upstream one, you would guess and say like, hey, I believe that those jobs upstream will never take more than 3 hours, so we'll start the next one at 3 a.m. And that was extremely fragile and error prone. And that's why workflow engines were invented. Instead of hoping and praying with overlapping cron schedules, you simply encoded the dependencies in a way that didn't ever screw up in the ideal world. Well, lots of modern data stack practitioners have actually somewhat de-evolved in this manner. They might set up managed services with an ingest tool, with a transform tool, with a reverse ETL tool, and be back to a world with overlapping cron jobs. And while in here, the crouched human with a computer is more efficient than the ape without the computer, they still are crouched. They still have regressed effectively to the state where they're dealing with a lot of operational fragility. And that's where Orchestrator comes into play. So we believe that for a lot of people operating the modern data stack, the orchestrator is a missing critical component for them. And in fact, will be viewed as a necessary component of the modern data stack, as central as the cloud data warehouse, a transform tool, an ingest tool, and so forth. The other thing that happens beyond just the operational robustness is that we believe there is a critical technology missing from this picture, and that is this, Python. So Python, or more generally custom code, will always have its place in a mature data platform. While you can do a ton of valuable transformation with SQL in a modern data warehouse, there will be cases where you need to do heavy transformation or filtering before it arrives in the data warehouse, or have a custom data source that doesn't have a pre-built connector, or simply custom scripts that maybe maintain the platform itself. Engineers are very resourceful people who come up with all sorts of reasons to write code, most of which are legitimate. After data arrives in the data warehouse, you'll again have valid reasons for turning to custom Python code. Machine learning workflows, for example, overwhelmingly rely on Python to create features and train models. Once those custom workflows become necessary, you'll see an exponential explosion in the number of dependencies that you need to manage. And it can quickly become unmaintainable if you're just using cron or ad hoc scripts to run and schedule those jobs. We believe that engineers should be able to wield and control Python transformations just as efficiently and conveniently as they're able to use dbt for their SQL. Orchestration, as a general category, has some baseline level of utility. Regardless of what you're using, your orchestrator should be able to easily sequence different steps in your workflows, as well as schedule and execute runs of those workflows. Explicitly defining the dependencies between your tools is generally less confusing and error-prone than having a wide range of overlapping cron jobs, each scheduling and executing a small part of your data platform. Orchestration also offers visibility into this execution. Generally, an orchestrator should offer a historical record of the runs that is executed, along with any relevant information about that execution. It should also be able to alert you in a variety of ways if something goes wrong. This in turn makes it much easier to learn about issues with your data without having to rely on a confused stakeholder noticing an issue with a query or dashboard. This would generally not be the preferred alerting mechanism. I want to talk briefly about what we think makes Dagster unique and uniquely suited to modern data stack practitioners philosophically. First, we believe that data platforms are built so that users can create data assets. That is why they exist. The pipelines we create are often responsible for creating or updating tables, models, external systems to reflect new information. And if these processes are orchestrated, it's natural that the central place to learn about these changes will be the tool that executes them. Similarly, we think your orchestrator should be intelligent enough to guide data from step to step for you. This tool that you use to run your steps should be smart enough to figure out how to pass data from one to another while generating useful metadata along the way. Next, the orchestration layer should feel like a boost in productivity, not an obstacle that needs to be worked around in order to execute your code. Dagster is built with the developer workflow in mind, with APIs that make it convenient to write tests that don't need to touch production databases, and a UI that makes it easy or even fun to work on and debug pipelines. Finally, because the orchestrator is often the only common component between the different technologies in your data stack, we see it as a natural system of record, not just for operational information, this run failed, this one succeeded, but for the structure of your data platform itself. Put more simply, it's where you define your data platform. One of the things we'd like to do with our data stack is to calculate a set of important metrics relevant to our company. To keep this simple, let's consider just a single one of these metrics, attribution. Metrics like this one require composing data from multiple data sources. Here, we need to incorporate information from our transactional database, purchase information, with information ingested from our ads platform, let's say Facebook, and our email platform, in this case, Marketo. For this use case, there's not really a need for any custom Python logic. We can do all of this composition in dbt as long as the correct data is in our warehouse by the time that dbt runs. The process of getting this data into the warehouse is managed via Meltano ingest jobs, which dbt can be said to depend on. If they don't run correctly, produce incomplete or incorrect data, then dbt will not produce the expected output, which can propagate errors through the pipeline. Trying to understand these issues becomes infinitely more complex without a centralized place to declare these dependencies. This code shows you how you might define those dependencies in Dagster. Each ingest job is its own Meltano ingest command. And actually, we just found this open source integration that someone who is not us wrote, which is super cool. And we use that pre-built Solid to do the ingest command. Solid is our node of computation. And we use a pre-built Dagster DBC Solid to run our DBT project. Let's see what it looks like in Dagit, our tool for visualizing and running these pipelines. So now I'm going to go to a live demo, which is always terrifying. And this is just a demo. We've deployed that code that we showed. And here you can see, it's a really nice UI. You can see what's going on here. And then we've actually been running this on a schedule. So if we go to the schedule here, we can see that, for the past 14 days, we kind of started kicking these off. And so we're running these every day at 8 a.m. UTC time. And then if we go here, we can see our historical runs. And we have all this nice information. But actually, why don't we just go and run this live? So in Dagster as well, you can just kick off you can just easily kick off manually arbitrary jobs. And so now we're going to do that. This is actually going to run live on a K8s cluster. I'm really tempting fate here by running this live on our demo cluster. Just takes a second to pop up because it actually has to kick off some ephemeral compute resources in K8s. Give it a second here. There we go. And so now you can see it's kicked off the 3 jobs that are ingesting the different data. This is actually invoking Meltano, although we actually kind of faked it here because sometimes that can take a long time. And then afterwards, it kicks off a DBT job. And here we can just demonstrate a few of our features. You see this structured log that's occurring that provides you live debugging. Another interesting feature, as I mentioned, Dagster is very aware of data assets that it creates. So now that the DBT job is finished, we can actually go and search for what we call the asset materializations that have been created. Go here, and here are these events. And they've generated what we call an asset key. And this allows you, in this case, to keep track of particular DBT models. So if we click here, we can see the executions of a particular DBT model over time, understanding how long they took to compile in DBT, how long it took to execute, and so on and so forth. This is completely user pluggable, and you can insert your own metadata, which is super powerful. But at its core, if we go back to an executed one, we have executed a set of processes distributed, in this case, across a Kubernetes cluster, and ensure that they execute in the proper order and to completion. This is kind of the basic use case of an orchestrator. But let's imagine that we wanted to go further than that. And we've seen a lot of this with our users directly, where they start out with a sort of out-of-the-box traditional modern data stack, and they have an ingest tool, they run some SQL using dbt and a data warehouse, and then maybe they use a reverse ETL tool. But let's imagine that same team wanted to support machine learning. And this is why, and we have seen users do this, this is why we believe there will always be uses for custom Python data processing. Regardless of how powerful modern data warehouses have become, there will be times where it's more efficient or intuitive to do custom transformation or filtering before data enters that warehouse or afterwards. At its core, Dagster is a data orchestrator. In the previous example, we were looking purely at operational dependencies. We had a sequence of commands that needed to be executed in a certain order, but no data was actually passed between those commands. That was done, say, within the data warehouse. However, limiting ourselves to configurations such as these is quite narrow. Data dependencies are really important and can be difficult to manage in other orchestrators. Dagster has first-class support for passing data between different nodes in the graph. So let's go back to Yukon, right? We've ingested data from our different data sources, but to better serve their top customer, Yukon wants to use correlated information, say add attributed purchases, to recommend products to their most influenceable customers. They've hired some ML people that work in Python and already actually having some custom scripts that written to take a batch of data and use it to train a model. Now they want to productionize it and get those same benefits that the ingestion workflow got. What's more, because this model is trained with data that is generated by dbt, it'd be nice if every time that a table was updated, our model also got retrained. So this is what this code looks like. It's just plain old Python. And imagine you'd written a Python script or you'd written Python in a notebook, and now you want to actually execute and do that data processing directly in Python. We think that this programming model where you write pure functions that take data and produce data with computation is actually philosophically very similar to the way that dbt models SQL. You can think of Dagster's transformation layer. And in fact, our users have articulated to do this as what dbt did for our SQL, Dagster did for our Python. Furthermore, we actually have the ability to do more intelligent things in terms of run instigation. So in this case, we actually hook this up so that there's two different pipelines, one for each team, but we still want the machine learning pipeline to execute the instant one of our assets get updated. So in this case, what we've done is the teams have said, hey, whenever a certain table gets updated, in this case, add attributed purchases, I want to immediately kick off a new ML training job. And that's what they've set up. So we offer this capability that's integrated with our asset catalog that just says, whenever this key gets updated, please execute my pipeline. Let's see what that looks like in reality here. So I go to this ML pipeline here. One, you'll be able to see that the structure of the pipeline, and you can kind of witness the logical data structures that are passed between those different steps in the pipeline. So that's super powerful and really convenient. But you'll see here, it's actually attached to a sensor. And what this means, oh, we just got it. This is actually polling and seeing when one of our asset keys gets updated. And you'll see that at 2:30 p.m., which is when I recorded this, it actually kicked off a job because the previous upstream DB job completed. And the moment that that table was updated, this kicked off. So two things have happened here. One is that an ML team has used the same technology and used Python to do data processing to construct a pipeline in Dagster, using the same tools that you saw before. And then the two teams have been connected through an asset sensor, rather than having an unencoded dependency or trying to slam everything into a single data pipeline. We think this asset sensor concept is extremely powerful because you can conceptualize the relationships between teams where their interface is itself a data asset. And I think this really falls in line with a lot of the talk that you've heard about data products. Data products are the relationships between teams. Dagster encodes that philosophy with a direct abstraction tool. So that's kind of the demo of Dagster and what we think about orchestration. I want to take the time next to kind of step back and talk about the modern data stack and where we see, we at Elementl and Dagster see it going. And you might have noticed that in this presentation, I sort of interchangeably use the term stack and platform. And notably, the name of this conference is the modern data stack. And I think it's worth digging into the difference between those two words. Is what we're building a stack, or is it a platform? We talk about this internally all the time. So first of all, what I want to do is define what a data platform is. It's really interesting because many of our users are on data platform teams or describe themselves as data platform engineers. But when you ask them, what is a data platform? You get a wide variety of answers that often don't make much sense. It's kind of a know it when you see it sort of thing. So we really spent a lot of time trying to more decisively and precisely, pardon me, define what a data platform is. What we define a data platform are the tools, services, and applications that store, transform, manage, and serve data once it has left its original source or system of record. That's a big mouthful. I want to dig into two specific concepts here. One is the original source, and two, system of record. So an original source would be, if you're building a web scraper, the original source is the web itself. If you're using an ingest tool, you're ingesting from a system of record. If you're using data generated from, say, sensor buoys in the Atlantic Ocean, like one of our users does, the original source is that sensor buoy. So with that definition, we can actually tighten this up. And a shorter definition, simply put, the data platform is where data is managed outside of its native context. When you have ripped the data from its original location, ripped it away from the software that manages it directly, and the data itself has been the subject of the platform. That's how we describe the data platform. And I'm gonna say something that might be a little controversial, and I think it might go against a lot of the philosophies of some of the other vendors and folks here. But Dagster has a unique view of where modern data platforms are gonna go and where the modern data stack lies within it. One of our claims and beliefs is that the future is more heterogeneous than the conventional wisdom in the modern data stack community says it is. Meaning that, we think there's a certain view of the world where you just have an ingest tool, a monolithic data warehouse, DBT over that warehouse, reverse ETL tools, and BI. And that is a sum total of your data platform. As we've demonstrated today, you very quickly expand beyond the confines of that once you want to do anything custom. So we have a few different beliefs related to that. One, we believe that off-the-shelf ingestion tools will not cover all use cases. Engineers will always have the need to write custom code above that. SQL will not eat all compute. We are in sort of a SQL maximalist phase right now, where I think some people believe that Python and arbitrary code is dying and that SQL will take over the world. SQL should be used whenever possible because it is the ideal and most accessible language for data transformations. But we fundamentally believe it will not eat all compute. Similarly, data warehouses will not eat all data. And I think one of the interesting topics here, which wasn't really discussed, is that we have open source components at every phase of the data platform, but there's this implicit proprietary technology beneath the surface. And that is the cloud data warehouse. Most of I would submit probably most of the listeners here use Redshift, BigQuery, or Snowflake, all of which are completely proprietary systems. We do not believe that these, with apologies to those vendors, we do not believe that those data warehouses, especially monolithic data warehouses, will end up eating all data. And if any of these are true, orchestration will be a critical part, and we think the decisive part of data management going forward. So we think that the modern data stack, I skipped here, but so as we've described here, the needs of a data platform quickly evolve past a narrowly defined version of the modern data stack. It would be probably more accurately called the modern analytics stack, because for answering the basic questions about a business with off-the-shelf ingestion tools, there's a reason why it became so popular. It's the easiest way to do that. But the modern data stack is either going to have to expand to include more and more technologies, or it's going to exist within the context of a broader platform. Now, whether it's the narrowly defined version or whether the stack exists with the context of a platform or the definition of the stack expands, what we do believe is that the principles that make the modern data stack so popular and so effective for so many people will live on. And so we think it's important that an orchestrator lives along with that. So one is a reliance and a default towards managed services and a stack that is explicitly defined for the cloud era. To go back to a previous example, the dominant data warehouses today, the reason why they become dominant is they were redesigned from scratch with cloud architectures and constraints in mind, and they just work dramatically better for users. Second, you default to off-the-shelf tools when possible, but those don't cover all the use cases. And for everything else, you want to adopt an engineering mindset. I believe that the modern data stack frequently has been misinterpreted as a no-code or low-code movement. I believe that is not only wrong, I believe that is precisely wrong. The flagship tool of the modern data stack, or one of them, is dbt. The entire premise of dbt is that it has transformed analysts to analytics engineers, meaning that it has kind of upgraded their skill sets. And most importantly, even if they're not classically trained engineers, they have incorporated them into a software engineering process. So you try to outsource as much infrastructure work as possible to manage cloud platforms. But for the business logic, the stuff that describes the essential complexity of your business or problem domain, you should apply an engineering mindset to that. And with that, I will wrap up my presentation. My Twitter handle or any other platform typically is Schrock. And then please check out Dagster. Go to Dagster.io. It's an open source project. You can pip install it. And then we also have a very active Slack community. And thank you so much for listening to my presentation.